Hello, and welcome to another video in the Designing on Particle series, where we walk through best practices and recommendations as you're building your particle-based products. My name is Eric Vosnacht, a solutions architect here at Particle, and in this video we will explore healthy design principles while developing your firmware. Now, if you haven't already watched the previous series videos, please do so as these videos build on each other. As we go through the video today, we will be reviewing and updating a simple loop counter application and then publishing that loop count at a set frequency. Now, although this application is simple in nature, it will allow us to explore some key design principles so that you can then apply these principles into your more complex applications. So today, we will discuss what we typically recommend for an application structure and the reasons why. We will implement all 4 of the particle primitives. We will review a couple of key aspects of building particle-powered applications, including system modes and threading behavior. We will also talk through DeviceOS Logger and Log Handler. And lastly, we will discuss some additional DeviceOS APIs you should be aware of when developing on our platform. So let's get started. Let's start with recommendations on the application structure. Here we have a simple counter application built using the Particle Workbench, and this has everything included to successfully develop a user application. Let's look at each piece in more detail. To start, we have included particle.h, and that gives us access to all the DeviceOS APIs, which is similar to Arduino.h for those who are familiar with Arduino. Not only that, you can even add additional header files for other libraries as needed. In addition, we will also discuss the various system modes and threading, and when to use each mode and threading configuration. We will also discuss the DeviceOS Logger, and it's super handy for understanding various aspects of the application, and I highly recommend using it. For the actual user application, we have our setup loop and our loop function that you will recognize if you are familiar with Arduino. If not, the setup function runs once at initial application startup, and the loop function will run continuously. Within the loop function, we increment a counter, which is a global variable defined before the setup function. Now, this counter is wrapped around logic using the timer function millis, and this ensures the counter is only incremented every 10 seconds versus every time the loop runs. If we were to increment the counter every loop, it would increment extremely fast, and that wouldn't provide much value. Note that this millis function is an alternative to using a delay function. However, using long delays is bad practice since each delay is blocking and it can cause issues depending on its length. That's it. Pretty simple, and this structure can be used for many applications, even ones that become super complex. Next, let's review how to implement particle primitives within the counter application. Here we have our simple counter application, except I went ahead and added and changed a few things, including adding the 4 primitives. Remember, we discussed each of these primitives in the first video of the Designing on Particle series? So I went ahead and added a publish, function, subscribe, and variable, each performing their own unique value-added feature within the application. In the setup loop, you will want to initialize all the primitives except for publish, unless you need to publish a message. As you can see here, we have our subscribe function, which subscribes to the event update counter and will update the counter value using the function called counter update when the event occurs. We also have our function primitive, which creates a function named reset counter that can be called from the Particle Cloud to reset the counter using the function counter reset. Finally, we have the variable primitive that tracks the global variable global counter that can be called from the cloud when required. Also, Within the loop function that runs continuously, we increment the counter variable, and then we publish that value using the publish primitive. Now, although this counter application is simple, you can think of this counter increment as reading a sensor and then publishing that counter or sensor value to the cloud, along with using the other primitives to update or reset the sensor as needed. This is really all you need to create an application using all 4 of Particle's primitives, taking a simple counter value and transmitting that value from the edge to the cloud and using the other primitives to add value to the application. Now, let's discuss system modes and threads and items you need to be aware of when using the various modes. System modes are a key aspect of firmware development. The various modes control how the device connects to the cloud. Automatic mode, as the name suggests, maintains and will connect to the cloud automatically. Semi-automatic works just like automatic, except the user can perform additional logic before performing the first connection. Afterwards, the system will ensure the connection is maintained. A good example of using semi-automatic mode is checking the battery level to ensure it is adequate before turning on the modem and connecting to the cloud. And as a matter of fact, we go through this exact example and implementation in the next Designing on Particle video, specifically focusing on battery-backed applications. And the last mode is manual mode, and this should be reserved for advanced use cases where full control over connectivity states is desired. And really, this should only be used in applications that require no connectivity, and for the majority of applications, automatic or semi-automatic modes are better choices. The system modes also work with system threads, so let's learn about the various threading options. The System Thread DeviceOS API allows the user to select whether or not the user application is blocked by having an active connection. When enabled, the setup and loop functions run immediately versus being blocked waiting for the connection. Our recommendation for most applications is that threading mode is enabled, which is contrary to how our counter application was set up previously. We're going to fix that. When threading is enabled, the function, variable, and subscribe primitives worked as we previously implemented, regardless of the threading configuration. The publish primitive, however, needs to take an item into account when threading is enabled. Specifically, you should avoid calling particle.publish before being connected to the Particle Cloud, as it may block the application loop. Therefore, it is recommended to add a connection check to ensure the device is connected before publishing. I also want to highlight that we also have threading APIs that are available for advanced applications that require it. We have guides available along with additional resources found on our document site. Let's head back to Workbench, fix the threading behavior, and learn how to implement. Here's the simple counter application we just reviewed with all the primitives implemented. Here you can see we have system mode set to automatic, because we technically don't need to add additional logic before the first cloud connection. However, if we were to require this logic, if this application was battery powered as an example, we would want to change to semi-automatic mode. Now, because we changed to semi-automatic mode, we need to call particle.connect somewhere in the setup loop, typically the last item. And then we just add whatever logic your application requires before particle.connect. I also want to highlight that a user should set up their primitives before calling particle.connect, as there's no guarantee they will be registered with the cloud otherwise. Now, the other item is system thread, and it is currently set to disabled. We need to fix this. This is because we don't want to block the application if the device isn't connected to the cloud. As I said earlier, threading should be enabled on most applications, including this one. Now, since we did enable threading, we also need to add a connection check to the publish. We just need to add some logic around the publish using particle.connected, since the API will return true if currently connected to the cloud. And with those 4 changes, we now have the counter application set up properly and on what we call the particle happy path. Now, let's review the DeviceOS logger or log handler. This allows users to add messages throughout their code set at various levels. Each message can be set to a certain level, and this allows you to easily turn on and off messages as needed. These levels include all, which is a special value that can be used to enable logging of all messages, trace, which is typically the standard for debugging purposes, info, warn, for warnings and non-critical errors, error, and none, which disables any logged messages. Note that all of these levels are inclusive of the lower levels. For example, setting to info will turn on info, warn, and error messages. Here's an example of the logger output. You can see that these are info level messages giving us relevant information about this application. Note that this is using our USB serial debug tool found at the link shown below, but you can also get this same output directly from Workbench as well. Now let's review the implementation of the logger class in our counter application. Now, to initialize the DeviceOS logger, it's as easy as adding one line of code to your application. Now, this initializes the default serial log handler and prints info, warn, and error messages to the USB serial port on the device. Note that there are other logger classes available, and you can even select different levels per logger class. And refer to our logger documentation for more details and examples on how to implement. Another item you should be aware of is the logger is also used within DeviceOS internals as well. Turning on logging will enable some of this, and it can be super helpful if you need logs to check out connectivity or other internal DeviceOS managed functions. Now, what if we want to add a warning message when the device is not connected to the cloud? But since we have the logging level set to info, it will publish info, warn, and error messages. But what if we want to see just warn messages? This is where we would want to set the level to warn. Now, in making this change, only the warning messages will be sent to the USB serial port. The key point to highlight here is you can add a ton of various messages and levels throughout your firmware. Then you can either segregate messages based off the level, or turn off all messages when the firmware is ready to be released by setting the logging level to off. Next, let's talk about additional DeviceOS APIs and features you should be aware of when developing on our platform. One key DeviceOS API you should be aware of is the Publish Vitals API, as it allows users to transmit diagnostic data to the cloud. By default, this publish occurs at every cloud connection and every 3 days. But if the application requires this information more frequently, use the Publish Vitals API. Another key functionality within DeviceOS is the file system. This allows user applications to take advantage of the external flash to record or log system data for use at a later point in time. And finally, you should be aware that we have a built-in JSON writer and generator that can be used to pack multiple data fields into each publish, function, and subscribe to minimize data operations. And the best place to learn more about all of these and the rest of the DeviceOS API is visit our documentations page. Now, let's quickly recap a couple of key takeaways from today. Follow the application structure we reviewed earlier and built on throughout this video. Leverage all the built-in DeviceOS functions specifically using our primitives. Implement a serial logger as it helps you monitor, troubleshoot, and optimize performance of your application. Understand the various system modes and threading to ensure your application is running as intended. And it is always best practice to use and refer to our docs for best practices, examples, and DeviceOS APIs. That's it. With Particles Workbench and our plethora of resources, your journey in IoT firmware development is both powerful and intuitive. Stay tuned for additional videos and collateral highlighting more features and functionality of our platform. Thanks for watching.